Extracting the research population, sampling frame, and sample size for a thesis involves carefully defining who or what you are studying, how you will access them, and how many participants or units you need. Along the way, it's important to understand key concepts like probability and non-probability sampling, random and non-random selection, and various sampling techniques such as convenience sampling, snowball sampling, and others. Let's break this down in simple terms with examples. The research population is the entire group of people, organizations, or items that your study is focused on. It's the big picture of who or what you want to understand. For example, if your thesis is about the impact of social media on teenagers, your population might be teenagers aged 13-19. If your study is about how farmers adapt to climate change, your population could be all farmers in rural areas of Colombia. The population should directly relate to your research objectives. To extract the population, ask yourself, who is affected by or involved in the topic I'm studying? The sampling frame is a practical list or database that helps you identify who can participate in your study. It's like narrowing down your population into a manageable group you can actually access. For example, if your population is teenagers aged 13 to 19, your sampling frame might be students enrolled in high schools across Madrid. If your population is farmers in rural Colombia, your sampling frame could be a registry of farmers provided by agricultural cooperatives. The sampling frame should be as complete and accurate as possible to ensure your sample represents the population well. The sample size is the number of participants or units you select from your population for your study. Deciding the sample size depends on your research goals, the type of analysis you plan to do, and practical constraints like time and resources. For example, if you're studying teenagers' social media habits, you might decide a sample size of 300 teenagers was chosen to ensure diverse representation across different regions. In quantitative studies, sample sizes are often calculated using statistical formulas such as based on a confidence level of 95% and a margin of error of 5%, the required sample size was calculated to be 250 participants. In qualitative studies, the sample size may be smaller, such as this study includes 15 farmers for in-depth interviews to explore their experiences. Now let's talk about sampling techniques. Sampling can be divided into two main types, probability sampling and non-probability sampling. Probability sampling means every individual in the population has an equal chance of being selected. This is often done using random sampling, where participants are chosen entirely by chance. For example, a random sampling method was used to select 200 teenagers from a list of high school students in Madrid. Probability sampling ensures fairness and avoids bias, making it ideal for quantitative studies where generalization is important. In contrast, non-probability sampling does not give everyone an equal chance of being selected. This is often used in qualitative studies or when access to the population is limited. Non-probability sampling includes several techniques. 1. Convenience sampling. Participants are selected based on ease of access. For example, convenience sampling was used to survey 100 teenagers who were available at a local community center. This method is quick and inexpensive, but may not represent the entire population. 2. Snowball sampling. This involves asking participants to refer others who meet the criteria for the study. For example, snowball sampling was used to recruit farmers for interviews, starting with a few known farmers who then referred others in their network. This is useful for hard-to-reach populations, but it can introduce bias as participants are often connected to each other. 3. Purposive sampling. Participants are chosen based on specific characteristics relevant to the study. For example, purposive sampling was used to select farmers who had experienced extreme weather events in the past 5 years. This method ensures you focus on participants who are most relevant to your research. 4. Quota sampling. Participants are selected to meet specific quotas based on characteristics like age, gender, or location. For example, quota sampling was used to ensure equal representation of male and female farmers from different regions. When deciding between probability and non-probability sampling, consider your research goals. If you want to generalize results to the entire population, probability sampling is ideal. If your study explores specific experiences or phenomena, non-probability sampling may be more practical. Understanding random and non-random selection is also important. Random selection ensures fairness, as participants are chosen by chance. For example, participants were randomly selected using a computer-generated list. This reduces bias and makes results more reliable. Non-random selection, on the other hand, involves choosing participants based on convenience, referrals, or specific criteria. For example, participants were selected non-randomly through snowball sampling. While this approach may introduce bias, it can be helpful for qualitative studies or when the population is difficult to access. To summarize, extracting the research population, sampling frame, and sample size involves defining who you are studying, where you'll find them, and how many participants you need. For example, if your thesis is about customer satisfaction in coffee shops, your population might be customers of coffee shops. Your sampling frame could be a list of customers from 5 popular coffee shops in Barcelona, and your sample size might be 150 customers surveyed to represent diverse opinions. Depending on your goals, you might use random sampling for fairness or convenience sampling for practicality. By clearly defining these elements and choosing an appropriate sampling technique, you ensure your study is well designed and relevant to your research objectives.